Welcome to the walkthrough for assignment 1A's frequently made mistakes. First and foremost, please don't remove the to-do tags, since otherwise it's hard for me to find where you've made your changes. Also, make sure to comment all your code consistently, and please don't remove my comments after you've addressed them. Leave them there so that the graders can see what you've done. Please don't be adding extra methods to the code unless you document them, and even then it's probably not necessary to add extra methods in most cases. Please also use simple code. There's no need in this particular case to create a local variable called being runnable and then return that. Just simply go ahead and return a new instance of simple being runnable with the appropriate parameter passed in. Let's now take a look at some of the issues with the runnable threads manager, starting with the begin being threads method. So as you can see in this particular case, if you're going to use the streams-based approach, there's no need to use for each ordered. Instead, you can simply use for each. And I recommend that rather than using for each and having to allocate the array list as shown here, that if you're going to go this way, instead you use the collect terminal operation with the toList collector factor method. That'll be more concise and it eliminates the need to allocate the array list explicitly. Inside of begin being threads, there's no need to use a synchronized statement here. This will not be a race condition, so you don't have to worry about it. There will not be other threads trying to simultaneously create this particular piece of code, so there's no need to synchronize it. Make sure that if you're going to be implementing the grad student version, that you call the set uncaught exception handler here as per the specification. And also notice that in this particular case, the m being threads variable, or field rather, is not being initialized properly. So make sure you do that, otherwise you're going to get a very mysterious null pointer exception. Going down to the bottom of the method, please avoid using for each loops whenever possible, and instead use the for each method with a method reference rather than a lambda expression. And by the way, you don't need to use a try catch block. Start will not throw an exception in this case. Let's come down here and take a look at another implementation. This approach is clever and uses the stream approach with collect. And that's great. Please, good job doing that. But if you're going to do this, make sure that you format the code consistently, as I've shown here, and also make sure you comment each of the aggregate operations to make it clear what's going on. Likewise, if you have m being threads, you can use the for each method on it directly rather than first having to create a stream, because for each is defined on a list as a result of the fact that list implements the iterable interface. And again, make sure that you use a method reference here as opposed to using a lambda expression. Let's come down and take a look at yet another example of begin being threads. This, once again, is the grad student version. Make sure that you integrate the creating of the thread and the adding of the m being threads with allocating the exception handler, the uncaught exception handler, and attaching it to the thread. Those things can all be done inside of one loop or one for each statement. You don't need to have two of them. That's extra work you don't need to do. A couple things here. You need to make sure that you're passing the appropriate method to for each. So as you can see here, this is passing in thread run, which is going to be completely nonsensical. It'll end up calling that in the wrong context. And so make sure you don't pass in the run method. You have to pass a different method in there if you want to start the thread. This is just a strange implementation. I'm not sure quite what it was trying to do, but it doesn't work, obviously. You need to do more than that in create and start waiter for being threads. Another important thing to remember to do, make sure that if you allocate a new thread, that you give it work to do. In particular, never say new thread, open close paren with nothing in here. There should be something in here, which is going to be a anonymous inner class, or better yet, a lambda expression. So make sure you do that properly. Once again, this is not how you start a thread. You don't start a thread by calling .run. That will end up calling the run hook method in the context of the calling thread. That's not what you want to do here. Instead, you want to start a thread and have that thread do the computations in the background. And then also make sure that you return the new thread object that was just allocated above rather than getting the current thread. Once again, you'll get the wrong result coming back from that, which will confuse things quite a bit. Here's some other things that can be improved in the create and start waiter for being threads method. So try to use a lambda expression instead of an anonymous inner class. Anonymous inner classes will give you the correct result, but they're more verbose and there's no reason to add all this extra syntax for no particular benefit. And down here, once again, there's no need to use a stream. You don't need to convert the list to a stream and then call for each on it. Just use for each directly. That'll be cleaner. And I also don't think you need to allocate another thread inside here. What you should be doing is joining within the thread that you've created. So no need to make another thread. That's just extra overkill that doesn't really help you. All right, now let's go ahead and turn our attention to the simple being runnable implementation. There's a lot of people making the same mistake here. So make sure you're careful about this. Also, make sure, of course, that you run your unit tests. They will tell you when you have mistakes like the ones we see here. So first thing you need to do is you need to make sure that you check to see if the Palantir that comes back from acquire Palantir is null. And if it is, you need to return immediately after displaying the appropriate error message using the error method. Don't be calling the gaze method on a null reference. That's guaranteed to cause chaos and insanity, of course. Next thing you need to do is you need to make sure that you put the code below, and I should actually kind of move this here. This code here is within a try finally block. So you need to be doing gaze within the try portion, and you need to be doing the release Palantir within the finally portion. And that's important because otherwise you'll end up having leaked Palantiri if the exception is thrown and you don't have a finally block to deal with that by always releasing the Palantir no matter what happens, whether an exception is thrown or not. Here's another mistake here. What you need to do is essentially move the check for P not equal to null outside of the try finally block. So you need to do that before you go into the try finally block, and that will clean things up a bit. Also, make sure you give a meaningful error message. Don't just give an empty string that doesn't tell the user what happened. And then here, in this particular case, because this is not being handled properly, this code is going to always be releasing all the results that come back from acquire Palantir, not just the ones that are non-null. So you're going to have a big problem if it ends up with a null. You check up here, but it's not checked down there. And in fact, it's better to rearrange the code to not do any of this stuff with having to check for null. So let's take a look at another similar problem. Again, make sure you move the call, these things up to before the try block, and then you'll also have to kind of hoist out the error message. Make sure you call the error method, not println. That doesn't give us the information in the right place. That'll do something strange on Android, which you don't want to do. And then finally, if you refactor the code properly, there is no need to check if Palantir is null. That will have been handled before you even went into the try finally block. And so as a result, there's no need to do the extra check. So those are some of the things that I saw people doing for assignment 1A. Most of these are very simple to check when you run the unit test. So you should be testing those things before you submit your code. Obviously, if you run the test and there's problems, come to office hours, post to Piazza, and we'll get you some help. And then also make sure you fix all these things, and these fixes should go into your next programming assignment, into assignment 1B. So assignment 1B will contain all the fixes for assignment 1A, and then assignment 1B will also contain the implementation, the initial submission for the Palantiri manager part of the house of the assignment. And then I will review assignment 1B, and then once you address those comments, then you'll get a final grade for assignment 1, which will include assignment 1A and assignment 1B. And you should always know pretty well what you're going to be getting as your grade, because if you run the unit tests, they will tell you if there's any problems. And if there are problems, then of course you're going to lose points. So try to make sure you fix all the problems before you do the submissions.